Okay, guys, welcome to Smarter R. So today I will show you how to do how to ranking the, how to aggregate the ranking of the rank GCM based on your previous work. If you usually at first we rank the GCM by using, for example, another statistical metric like NSE or R square, and then based on that ranking that we have, because we have so many grid point, right? Somehow we need to aggregate all the rank of each of that grid point and then find which GCM is the best based on the aggregation of the ranking. Some study area have 178 grid point. The ranking will be different. The capability of GCM will be different based on different study, different grid area. So that, but somehow we need to find which GCM is the best overall for all this study area. So to do this, one of the method that we can use is we can use compromise programming index, and then I will show you how to do the how to select the subset of GCM by using Fisher-Jenks also later on. So let's share the screen without further ado. Okay, entire screen. Yeah. Okay, it's there. Okay, now this is the code that we have. Okay, first you need library BAM tools, this BAMM tools. If you don't have this library in R, make sure that you install this library first. So, okay, I have installed it, so no, doesn't have any problem. And then you read your working directory. This is your working directory where you put your dataset. So in this dataset, I have this result section, result data, which is in the CSV file. So my data is in .csv. So the data is this one, stat PM, this one, KGE. So this is the input data that I have. This is the working directory, which is the folder of your, the address folder here, the folder of your folder, the address of your folder, and then this is your CSV file. So open that CSV file. So as you can see, this is the CSV file. I have V1 until 178. So I have ranked all this grid point, and I want to identify which GCM is the best, something like that. So each GCM have their own ranking based on KGE. This is the example for KGE. So to prepare this dataset, make sure that after you have this dataset, make sure the first column is removed. Make sure that there is no column in another column. The first column will be V1. This take particular attention for this one. Start from V1 until the end of your grid point 178. In my case, 178 for Peninsula Malaysia. So remove the first column, which is the GCM name, remove that one, and then save this dataset. So we will read this dataset as input data. So we read this one, and then we calculate the maximum value for each of that GCM, each of that column just now. So we calculate the maximum value. Why we calculate the maximum value? Because for KGE, the best value is 1. The highest is 1. The maximum is 1. For NSE also, the maximum is 1. R square also, maximum is 1. So we use max here. So we use apply function, calculate the maximum value for each GCM, and then we initialize the CP matrix, and then in row res, initialize the CP matrix, and then we calculate the CPI this here by using CPI. So CP I did as numeric res. This is to calculate the CPI. So and then calculate CPI value. So higher CPI value are better since 1 is the best. So we use this calculation to calculate the CPI value, row sums of CP, and then divide by and call res. CPI equal to row sum CP divide by and call res. And then convert CPI to a matrix where higher is better. We make sure max CPI and then there's CPI. And then we rank the GCM based on CPI. Higher values are better. So you make the order, which is decreasing, so higher and lower for the CPI. So we run this OD, and then the GCM, list of the GCM. So take this attention for this one also. The list of the GCM, because we removed the GCM list just now, right? And then we need to put it again. So make sure you open the list of your GCM part in D. I put this file here, which is in D, research, subclaim, analysis, relative importance, MIP6, final. So I put this CPM list here in this folder, and then put all your GCM, list of your GCM. Doesn't matter if it has input or empty is okay. Empty also okay. No need to have anything. You just put what it want to capture is only the name of this GCM that you have. So in this case, I have 23 GCM. So I put this name. Any Excel file, you put the name and you put it here. So 23 of GCM here. So this is we put again the GCM name so that it will properly rank into the CPI later on. So list file here, and then GCMs is OD, and then CPI OD. And then we create output data frame by using data frame function. This is now we rank the GCM. CPI equal to CPIO here. We rank the GC. Now we get the output. That's all. Now we have the output for white CSV rank. We already ranked by using CPI, and then the output will be this file, CSV file. Row names is equal to false. Any name you can put here, but I will use KGE2. Okay, I will write here. So this is the output that we have, the new output. You see, you will get this result. So this is the CPI value. The higher is better. And this is have CSV, you can just remove this one. It can be removed easily. You can just put like this: data, text to column, delimited, next, add dot, and then next, finish, and then remove that CSV, and then you have all your result here. Which GCM is the best? So in this case, this is the best GCM. Okay, this is only for KGE. Now we rank for KGE. After we rank for KGE, in your case, you have another, right? You have NSE and some so forth, something like that. So now I will show you how we need to rank for. We need to do ranking for another one. For example, I put it here for, in this case, R square. So R square. So let's see where we put our SPM final correlation, R square. So I put it here, take this data set, and then the same code, but now we do for R square. So R square is this one. This is already the result. What we want is this state. Remove the first column also. The first column, remove that one. And then get the result for R square. So put it for R square here. So it starts from second column. You see here, we run this one. And then the same thing, you run for, because R square is also maximum result, is the best. You run this one, you can get, and then run the GCM folder with the GCM name, and then rank it. Now we get for R square 2. So I get this result, R square 2. So this is the output. You see, you will get different result for under R square. So you see different statistical metric will give you different result. but there is some homogeneity there, but you can observe by your own. But this is the result for R square. So the best GCM is BCC, IPSL, Sesame, and Chem something like that. So this is the result for R square. So we have this result now, CPI for that one. Now we need to re-aggregate. It's better if I run for NSE now also. I think, let's see, I think if for NSE. So let's see for NSE. So NSE is efficiency matrix. So I put NSE also. We run everything. So this is NSE, and then we have state here result NSE, then run this one. So now we run for NSE. So we run the same thing, we just run everything. And then this one will be for the final. Okay. Now this one NSE 2. Okay, now we have NSE. Okay, now this is the result for NSE. So see, this is the ranking for NSE. So I will remove this one. Data, next. Dot, next. Finish. Okay. So we have all the result for NSE, KGE, and R square. Now what we need to do is we need to re-aggregate that ranking. So to re-aggregate that ranking, I need to check my code first. Aggregate. Okay. It's here. I think it's here. Don't worry. Combine result matrix. Okay. This map. Compromise programming. Searching. Okay. Statistical performance matrix. Combine selected statistic. Okay. This is validation. Convert. CPI refine one. So this is this one. This is another method. Like to now we have MSE. I do a lot of assessment for by using a lot of different metrics last time. So now we combine the result. We combine that one. Okay, we can combine. And then do the heat map also. So here, what we can do is that we can combine that the output that we have just now. So we have correlation metric. We have correlation matrix here. So it's not here. It's got okay. We have correlation. Why is not? See, it's changing. Okay, correlation metric, and then we also have, and then we have 3 just now, right? So correlation metric is R square here. So we have the R square, GCM for R square, and then we also have efficiency metric. You can just combine copy here. Efficiency metric for NSE2. This is what we have that we prepare just now, and then we also have for correlation matrix. Not correlation. Composite. I think composite matrix. Okay, we have composite matrix. Composite matrix for KGE2. So the arrangement doesn't matter. So now we combine that 2, 3 until 2 and 3 only. So this will be R square NSE and KGE. Now, so it will be in the composite matrix here. Our output doesn't matter where what it will get wherever the folder that you have, it will be there. The result will be there. So I will put this special grid final. Okay. So we combine the result just now. Now we have this final. Okay, grid final. So as you can see, this is the ranking of the ranking of the the ranking of the GCM that we have. You see, R square and SE usually have mostly similar one. Oh, it's mostly similar, NSE and R square. But KGE is quite different. It's quite different. I'm surprised also. R square and NSE have similar result. Yeah, somehow it gives you similar result, but it's okay. That is the result. So we use that result. So now we use that one just now. Get that final ranking. Get the final one, GCM ranking. Do the heat map again, and then so I use this. I put this here RIM because in my code it was RIM, so I don't want to disturb much of this. We remove this RIM actually, and then run this code, and then you will get the heat map for that for that aggregate ranking for the GCM. So you can see most of the best GCM is this one, BCC, CSM, CH, I don't know. You see some of it, the ranking is quite similar between KGE, NAC, and R square. The worst GCM is also quite similar. So you can see the similarity between the GCM that was being ranked here. So you can use this one to visualize the aggregate of the final ranking because you use three heat map previously, right? And then we aggregate the ranking, and this is the final ranking for your GCM. Now you can re-aggregate again this result. Actually, you can re-aggregate again. You see, you have this one. So to re-aggregate this again, you will need this it's okay. Now you already come here. Later on, we need to re-aggregate again. I will show you how to re-aggregate it again later on because now it's quite late. I will check the code again tonight. So this is how you use CPI for re-aggregate the ranking because just now we already re-aggregate the ranking. You see, get this ranking. Now we need to, this is subjective. This is actually quite subjective because you can do another ranking again. It's up to you. But I think it will be better for you to do re-aggregation again. And then after that, we will run for the final GCM. We will run for Physigen to select either we want to select the top 5 or top 3 or top 10 or something like that. It's depend on the Physigengs later on. But later on, I will show you how to re-aggregate the ranking again. So in this case, I think we can do this. Yes, so let's do this. Let's do this. So we have this one, right? So I will do this as final rank. Okay. So I will put this is KGE. This is KGE. And then we have correlation matrix R square, because I don't have time. We need to do this now, otherwise this we have R square. So I put it here. And then we also have efficiency matrix just now. Here, NSE. Okay. Just create another folder. So we have NSE. So this is the composite matrix. I put it here just now, right? Oh, where is it? Final rank. This one, final rank. So you must arrange this dataset in order again. Let's do this. Sort by filter, sort A to Z. Sort A to Z. So it will go A to Z, right? So first one is KGE. And then the second one, let's do this A to Z again. And then for this one, you do sort A to Z. So now you can remove this value, delete this one, and then delete. Okay, now you have KGE, R square, and NSE. KGE, R square, and NSE in particular order of the GCM from A to Z, the order. So now we aggregate again the GCM. I call it final reaggregation. Final aggregation of rank GCM. So we put this one composite matrix just now. So composite matrix and the final rank. So this is our final rank. So it start from column 2. Let's see. One again. One. Okay. Just run the same CPI code. Just change this one, GCM, CMIP6, final rank. I'll put this one as final rank. And then this will be final rank. So we have this is the final rank of the GCM. Now we have the final output. So it still they have CSV there because it's from the folder of GCM list. Can remove this one. So this is your final GCM selection. So the best one is BCC CSM2MR, and then followed by this one, and then so forth. So this is the best GCM in your case. But we need to find which GCM is the best, right? We need to select the subset of the GCM. So to select the subset of the GCM, we can run this Physigen breaks classification method. So for this case, you need to install can remove this one, library class in, and then put where you put your your input data just now. It is in composite matrix, and then I will put the result for final rank. So this is the result for final rank. Okay. Now this is quite subjective. You need to change here the number class. We need to test is which class, how many classification is the number of the top GCM will be more stable. Maybe we start from 5. Maybe start from 5. So we run this one and then run custom Fisherjang function here. Run this code and then compute the Fisherjang, extract the result, and then print. You can see there's the result print there. So, but here we will need to Fisherjang's back. I put 5 just now, right? Try 5. So I will try 5. So when we look at the result of number 5 here, we can see that this is the result, right? So the best GCM is 1, 2, 3, 4, 5, 6. So the top 6 GCM here, the top 6 GCM is the best. We need to select this top 6 GCM. 1, 2, 3, 4, 5, 6. So this is the subset of GCM, but we still don't know we should select this 6 or not based on this result just now. You can see this similar number is one group, similar number is one group, and another similar number is one group, and this is one group and another group. Now we try to run for 6. Change class to 6. Change class to 6. And then run again. Run 6 for 6. Maybe we try 7 also. Try for 7 also. And then run. 7. And then maybe we try 8 also. We just want to see is it still that 6 GCM is the best or not. So okay, now we find okay 5, 6, 7, 8. Now we look at number 6. It says 1, 2, 3, 4, 5, 6. Oh, number 6 GCM is still the top one. Number 7. Now it's changed. You see, 3 GCM is the best. If we use number 7, 3 GCM is the best. Number 8, 3 GCM is still the best. So you need to select 3 GCM only. So now we maybe try number 9, class 2, 9. I think 3 GCM is okay. So you can download the future projection for that 3 GCM only in the future. We try 9 and 10. Try 9 and 10. Okay. And this one. Now we look at number 9 and number 10. No. Okay, let's see. Number 9. Still, it's very stable now. It become very stable. Number 9 is still top 3 GCM. Number 10. Number 10, now it's changing. So number 10 only give you 1 GCM. So this is not good. So as you can see just now, from number 8, I think number 8. From number 8, maybe 7, let's see. From 7, when we classify from here, when we classify from 7 to 9, it was stable. Until 10, it's only give you 1 is the best, the top one. So use you can use any classification 7, 8 to 9 and tell that based on this 7 class that you made or 8 class or 9 class that you made, this top 3 GCM is the best, top 3 GCM. So you can call this as class 1. This top 3 is class 1. This is class 2. Why I feel like I'm rushing. This is class 2. And the rest is class 3, 4, 5, 6, 7, 8, something like that. So only select this top 3 class. So this top 3 class is which GCM? This top 3 GCM is this one. So now you have your subset of top GCM. So this is your top subset of GCM. So use this GCM, download the future projection for this GCM. Later on, we will bias corrected only these 3 GCM. These 3 GCM, after we bias corrected, later on, after that, we will ensemble. And then we do finish with future projection. So almost finished actually. Now you need to select which GCM is the best in your case. I think I cover everything, a lot of it from aggregate the 3 metrics that you have just now. You must aggregate the grid point for each metric first, and then re-aggregate again, final re-aggregation for that three metrics, and then run the Fisher-Jenks, and then you will get the subset of the GCM that you have. I will share this code to you. Somehow it's here. So I will save it as Mrs. Abdul Mumin. Okay. CPI and Fisher-Jenks. Okay. Okay. I think that's all for today. Thank you for watching.